so if you look at your alkyne and you look at your alkane, you can see the difference. And then you know that acidity is related to the, the stronger the acid, the weaker the base, or the more stable the base. And then you can see that this base is stronger base, meaning it's not unstable, meaning its acid is very weak, and then so on. So just pay attention to relative stabilities of the base or acidity, comparing them. Also pay attention to water versus ammonia, and then of course deprotonated water and ammonia, where they are. So having said this, I lied. There's actually one more thing here. Surprise! I didn't lie. I omitted this. It's really not a finished mechanism, a reaction, so I don't want to say it, but let's just put it here so you're aware. Strong base. And when I say strong base, something like this, or existence can survive something like this, or like that. This would be a nice possible base. So something like sodium NH2, right? So basically what this means is NH2 minus. Something like this. Anybody? Is there a reaction here or not? Anybody? We are trying to deprotonate alkyne. Is this possible? Can we deprotonate this alkyne? People say yes. Are there any protons next to the triple bond to deprotonate? Yes, no, yes, no, yes, no. No, there is no terminal. This is not a terminal alkyne, right? So if I put a strong base, it might deprotonate this, but that's not a very stable, your reaction will go backwards. So this is not useful. But if I have an alkyne like this, then what do we get? Anybody? We are deprotonating this, right? Like question 50 on your exam, 1. We are deprotonating this. Then what do we get? Right? Basically, we're using this alkyne. We put some strong base, and we can remove one of the terminal protons. Here I have 2, and here I only have 1. On this side, right? There's a proton here I didn't show, but you can remove that proton and end up getting this, right? So that's one useful reaction. Obviously, I didn't show you the end. Something happens later. I think I have a next slide. But this reaction, I am calling your attention upon because this reaction can give you this, which is acetylide or acetylene anion. I think I have it here. So if you have a I don't want to show you that, you don't know anything about it. But if you just ignore everything else and you just focus on the left-hand side, you can see carbon, negatively charged carbon, negative carbon with a lone pair. That's the same thing. The lone pair is the same. So that's what we form. So that's useful. So a reagent that can give us a acetylide or acetylene, this thing, that reaction is useful. So this particular reaction with a strong base is useful because you can form this acetylene, acetylide. And it's useful because this particular nucleophile can then attack. And I know this is foreign. This is foreign because this is the next chapter, or chapter after next chapter. So you don't know much about this. But basically, it's a useful way of making longer organic compounds. You see how we start with 3 carbon, we use this on 4 carbon, and we can make something that's much longer. So it's a nice way of making longer organic or carbon chain by using this starting here. So this reaction I don't want to omit. This is a starting reaction where you can make this anion. It's useful. So in this wheel, please remember this reaction as well, which works only if you have a terminal alkyne. Okay, this is we're going to see later. Don't worry about slide 14, okay? I'm not going to test you. I take that back. Do not worry about SN2 reactions or SN1 reactions. do worry about acetylide and this right here. Okay, here's a nice question. Now that you have many reactions with alkenes and many reactions with alkynes, question like how to make this product from this starting material. So we can call this is a new type of exercise. We've never done before. So far what we looked at was starting material product, or starting material product, what's the reagent? It was a one step. So BH3 was a two-step really, but it's still considered one-step synthesis transformation. So here what we're asking is how do we make this product from this starting material? This type of question will not be on the exam 2. The exam 2 will not have a synthesis.